It's Brad's Laboratory.
Okay, this is a TV my wife got from her work. It is broken, no power whatsoever, no picture, no backlight, no nothing. So here I am taking the back cover off. It didn't come with a power cord or a remote. I scared up the power cord. I'll have to order a remote off Amazon or eBay. Now we got the back covers off, and I plug it in and I start checking some voltages. The first thing to check is always the fuse. Sometimes they can look like they're not blowing and they're blowing. What you do is you put your meter across the fuse and it should read 0 volts because there's no voltage across that fuse. There is voltage across the fuse when it's blowing. If your meter reads 120 volts, then your fuse is blowing. The next thing we check is just the input voltage AC. I wanted to make sure that power cord I got was good. I found it on my scrap bin, but it turned out it was okay because we had 120 volts there. Then I start checking some of the DC voltages up on this connector that feeds the main board. And those were all 0 volts. The thing was blowing. Now that I know that for sure that I have a power supply board problem, I can narrow my search down to just the power supply board. Okay, so here on the power supply board we got 120 going in, and then it's getting switched. This has gotten really hot over here, and we got these 2 capacitors that are blowing. So this one's blowing, goo's coming out the top. This one's blowing and vented its top. So hopefully we can just replace those capacitors. Those ones look okay. These small ones over here look okay, and these ones here look okay. So 10 microfarad 450 volt. I don't know if I have any of those. If I have to order some. Okay, now go ahead and take the power supply board out. This is just like, I want to say 6 or 7 screws. Pops right out pretty easy, and you just pop the connectors loose. Immediately we noticed that there's a problem there. That bank of resistors has gotten really hot, and that's what's caused this deformation of the board over here. When the capacitors blew, these resistors sucked a lot of current, and it just toasted them. You can see the board even caught on fire. So these all have to be taken out and new resistors put in place. These resistors are never going to work again, and laying on top of the circuit board that is now the carbon pad here will never work. That will actually add resistance and just cause problems. So we'll go through and we'll pick all these resistors off, and we'll relocate them off the board, and we'll use a lot higher wattage resistors. The next problem I got is this trace here. When those resistors are all removed, this trace is going to be damaged. We're going to have to figure out how to get that trace replaced. So I think I can get that one. It's right below this. There's no hole there, but I think I can drill a hole from the back side up and then get my wire on the top side. And then the other side of these resistors goes to this transistor, and there's a hole drilled right there next to it. To where I can get my wire in there. So the plan is
bring that wiring out over here, and then put some like 10-watt sand resistors. Just glue them on with some Celastic over there and make a connector so the board can still come in and out. So we'll fix that, and we'll fix these two caps that are blowing, and put her back together, and cross our fingers she fires up.
Okay, here I am. I'm just continuing to get those resistors out. I probably should use a different pair of dikes. These were a little dull, but managed to get them off and clean things up a little bit. I am guessing these resistors are 1/8 watt, so we'll use that when we calculate the total wattage. Then here I am, I'm fixing that trace. I've decided to put a new wire all the way from over on the side of the board where the capacitors are over to where the resistors were. So I just bend that to match the trace that I'm replacing, just so it looks nice. No particular reason here. So now I'll have a good copper piece across that carbon, and it'll be insulated because of the green insulation on this wire. This is just wire from a piece of network cable. I really like how the color of the wire matches the solder mask of the board. So here I am just stripping it and getting it on there. It takes a little bit to down the damaged traces, but we eventually get them. Once that looks pretty good, then I break out the epoxy. So I just made that match exactly to the trace. It looks pretty nice there. Mixing up some epoxy, and I glue the wire down so it won't be flapping around in the breeze. I'm also going to epoxy the area where the resistor bank was to try and keep that carbon from going anywhere else besides the board. So I just use a couple things to hold down the wire while it dries, and I use up the rest of my epoxy on the burnt area of the board. This slide shows how I figured out the resistors. I actually downloaded a new board picture off of eBay that someone was selling, and did the calculations from there. You couldn't really tell what the resistors were because they were so burnt up. I figured that these resistors were 1/8 watt resistors, so that gives me about 3/4 of a watt across each parallel section of resistors. I overshot that with a 10 watt resistor, but I really didn't need that much. When I made my mistake, I paralleled a couple of 22k ohm resistors that I had around that were 1/2 watt that cut the resistance value in half to 1.1k, but it doubled the wattage from 1/2 watt to 1 watt to cover the 3/4 watt that it needed to dissipate. If you're doing this, of course, you could just do it with 3 resistors, a 20k, a 25k, and a 330 ohm, and 5 watt resistors would be adequate, more than adequate. Here's my little connectors. I ordered way too many of these, but I'll be using them on other projects. You always need a little splice here or there with a connector. I'm just going to put those on. I did drill a hole there where I was talking about it earlier, and that red wire just slides through there and solders on. Pretty easy. And then the black wire gets cut and gets put over by the transistor. It's worked out pretty good. I put the resistors on the opposite side of the board where I was going to put them originally, but I think that was better anyways. There was more space over on that other side. I was worried about the case coming down and hitting the resistors. It was like a coil, and I had pulled it off just to make sure it was okay. Got quite hot, but it turned out to be okay, so I just put a little KAPTON tape to keep the burnt board from causing any problems. Here I am soldering up the original 4 resistors. These are 10-watt resistors, so they were going to spread the heat quite well. Later on, realized I'd made a mistake in my calculations and I had to add in another couple resistors. But basically the idea was just to solder these together to make the required resistance value and add a connector. So all in all, pretty simple. Gets the heat from these resistors off the board if the capacitors ever go bad again. They were all in parallel on the board in order to provide a higher wattage rating for the total amount of resistors. Here we are, just about done connectorizing these resistors. We got them looking pretty good. The resistors are now connectorized. Cut that last wire. I'm putting some KAPTON tape on the chassis, the metal chassis there. I put 2 layers of KAPTON tape. Then I put on this silicone, push the resistors in there. At this point I realized, it was about a week later, I'm still waiting on the 2 capacitors to show up, and I realized that I had A, made a mistake on my resistance calculation, and B, the old silicone I'd used was never going to set up. It was a week later and it was still not set up. So I used some paper towels to clean it all off, clean up the resistors, and then I went ahead and I added a couple more resistors to bring up the resistance value of the array there. These were just some half-watt resistors I put in parallel to give it like about a watt of power rating. And again, pretty simple, just wired them in. This black wire had been giving me a lot of trouble, but I finally wrestled it in place. Little dab of solder, and she's ready to be installed. I got a new tube of silicone that went in a lot better. Glued them in there really pretty good. Got a lot underneath the resistors. And here's my capacitors. I specifically ordered these Panasonic capacitors, and what came in was not Panasonic capacitors, so be careful of that Amazon seller. I definitely got ripped off because these are unbranded, not Panasonic, and I specifically wanted some higher quality capacitors to go in here. So it kind of pissed me off a little bit, but I went ahead and used them anyways because I'd waited a couple weeks for them at this point and needed to get this TV done and out the door. I will say I don't have a lot of confidence in those capacitors. So here I am, I'm just putting those capacitors in. I put both of them in dry, flip the board over, solder them. And you know, this doesn't take very long at all to solder these capacitors in. Clip the leads, and then I put a little silicone in under each one to hold them down. And then I put a knife on them to hold them down while the silicone dried. So here we are a long while later, everything's fine. Put the board in, ready to go. So connector connected up, put all the screws in. There's one screw here that is larger than the rest of the screws, and it goes in that hole, and it's got a star washer on it, as you can see there. There's just that one that's going to trip you up. Otherwise, all the screws are the same. Alright, here we are. We're gonna check some voltages before I plug in the rest of the wires. And yep, yes indeedy, we have 12.79 volts there, so the board is working again. We can go ahead now and plug in the rest of the wires and see if the TV fires up. So here I am plugging the rest of the wires in. Kick it on, and bingo, we have a red blinking light, and away we go. Okay, beautiful little red blinking light we got. I go over and I look and I can see the backlight lit through. I can see some LEDs lit up there, and I can see the backlight lit through these holes in the chassis there. You can definitely see that it's all lit up and seems to be working now. There, I turn the TV off, and we'll go ahead and we'll put the back on it. I'm pretty confident that I got her fixed, and just so confident I'm just going to go ahead and slap the back on it. Takes a little while because there's a lot of screws on this thing, and I like to use a manual screwdriver when I'm putting stuff back together, especially when screws are biting into plastic. If you use the drill, it's going to over tighten things and cause problems, so I just do the final assembly with a hand screwdriver. Helps me feel things better. Last screw, power. Here we go, and yeah, we have video. Now I got it inside, and I got it hooked up to my Roku, so you can see it's working just fine. Perfect picture. You can kind of see what I like to watch on Brad's Laboratory channel. Hi, Brad here. Thanks for stopping by my channel and checking out this video. And really appreciate all the new subscribers. I made it to the 1,000 mark before February 20th, which was a big milestone for keeping my YouTube monetization. So thanks a lot. Picked out a couple videos for you. One over here, selected video, and if you can subscribe, really appreciate it. Talk to you later. Bye.